Hey, welcome back. Today we're going to talk about while loops and if-else structures. I think this is going to be really fun for you here. Let's talk about a while loop. A while loop is a structure within Robot C that allows certain codes to be repeated as long as certain conditions remain true. What they're talking about here then is, let's make this a little bit smaller here. A while loop. All right, three main parts to every while loop: the word while, the condition, all right, and the command to be repeated. So what happens is it allows this, creates a loop where this keeps repeating itself over and over again. Maybe you want the motor to run for a second, off for a second, run for a second, off for a second, for a continued pattern, without having to type out a really long one. Maybe you want this to happen and continuously, unending. You could use a while loop for that. The word while, all right. Every while loop begins with the keyword while. All right, so we'll start there with this. Notice that at the end of while, right here, there's not a colon. This is not a command. All right. Here's where you're going to put your commands. Condition controls how long or how many times a while loop repeats. The condition is true, the while loop will keep repeating. When the condition is false, the while loop ends and the remainder of the program executes. So in this case, for example, they're showing us the condition is checked once every time the loop repeats during this property here. So but this is this condition. We're going to talk about the condition here pretty soon. Here's where the command would go, all right, in between the curly brackets. Program decisions are always based upon questions. Only two possible answers: yes or no, true or false. Statements can only be true or false are called Boolean statements. Their true or false value is called a truth value. So here is some Boolean logic. Condition: sensor value. The sonar sensor, for example, is greater than 45. Is the value of the ultrasonic sensor greater than 45? If true, all right, then it's going to run the program. If false, then it's not going to run the program. All right, some conditions. 1 equals 1. Ask yourself, is 1 equal to 1? Yes, if it's true, then it's always going to be true. Is 0 equal to 1? Is 0 equal to 1? Well, it's false. That's always. So this 1 equals 1 is what we're going to use quite often. All right, and what that tells us is as long as 1 is equal to 1, keep running this program. All right, and that's what we want to really focus on. Some of these other ones we'll get into eventually. Our robot symbol equals equals, the double equal sign is equals to, is not equals to, is less than or equal to, is greater than or is greater than or equal to. So we can put all of these symbols right here where it says condition. And again, while that condition is true, that's how long this program is going to keep running. All right. So writing a condition, example of that. While the bump switch is not pressed, wait until it's dark, then turn on the light. Wait until it's light, then turn off the light. So while the sensor value, well, which sensor value? The bump switch, all right, is equal to 0. All right, that means we haven't touched it yet. All right, so while the sensor value, bump switch, is equal to 0, all right, Boolean logic, parentheses, controls the loop. So here's what I want you guys to see this. Notice that the whole thing here, everything that our while statement is in parentheses. All right, inside the parentheses comes the word sensor value. You're pretty much going to have to put that in there. All right, and then you're going to have a bracket, a bar, all right, a hard bracket. You're going to put what sensor value are we looking for. This right here, we're going to talk about the bump switch. Hard bracket is equal to 0. And then we have our curly brackets, the soft brackets here. Again, notice no colon. And then our program, our commands go in here. A while loop is more flexible than an until statement. A while loop can do the same thing as the until statement. Example code using until statement. Start motor until sonar less than, in this case it'd be 50 centimeters using the sonar, and when that happens, it's going to stop the motor. But a while loop will do the same thing. Start the motor, left motor, full speed, while the sensor value is greater than or equal to 50. So they've changed the word here. This was less than, but they want it to keep running. This is telling it when to stop. This is telling it to keep running as long as it's greater than or equal to 50. All right. If that changes, all right, if that becomes no longer true, it's going to stop the left motor. And that's what they're telling you here with that. Okay, what I want to point out here with this as well is inside this brackets we can control other outputs. All right, if we do a while statement, we could put in here until bump. You could put then an until bump in here, and one of the things you're going to be asked to do in an assignment is called an emergency shutoff. And inside these brackets you could put in there until bump, and you could say bump switch, stop left motor. All right, so you could put that in there, and what that would do then is this would keep running on two conditions. You'd have your emergency shut off by saying until bump, by putting this inside the brackets, and then you'd still have this would keep running, and then you'd have two ways shut this off, the normal way, and then your emergency shut off as well. Okay, here's what I want to show you out of this one. Right here, this double and means and. So this gives you a range here. All right, what this allows you to do here is we're saying that while the sensor value, the sonar, is greater than or equal to 50 centimeters and the sonar is less than 70. So right here, this is giving us this range. It doesn't have to be just automatically greater than or equal to 50. We're also saying that it's less than 70. So this symbol right here allows us to be able to use a range when it comes to using these while statements in our sensor values. Timers. All right, timers are loop for control where you would wait a statement go if we wanted the loop to repeat for a controlled amount of time. Nowhere, we need something else. How about a timer? There's 4 internal stopwatches available with the VEX. Like encoders, timers should be cleared before they are used. Be careful, don't clear a timer in a timed loop. Okay, I want you to look at the top part of this up here. Don't focus on this down here because we're getting ready to talk about if and else statements. But up here, clear timer. So we're talking about the first timer, timer 1. And then we're going to use this timer. While the timer, timer 1, is less than 30,000, which means 30 seconds, then it's going to run this, which means it's going to run this for less than 30 seconds. It's going to run it for 30 seconds. As soon as it gets to 30 seconds, bam, it's going to stop. And that's what this timer here is for. So this would be a way, instead of a number of times, you could or instead of using a number of loops, you could use this timer and say, I want this loop to run for this amount of time. And that's how this helps us here. This is how we use a timer. Let's get into this if-else statements here. Okay, I think I want to go over here real quickly. Clear timer, that's a command. You'd have to have a colon after it. But while you're talking, the while statement that involves the timer, it's not a command, so there'd not be. All right, if statements. An if statement is a program is evaluated by the condition contained in the parentheses. If condition is true, then it's going to do what's between the brackets. All right. Else, it would do something else. So in this case here, if else statements, they're saying if this condition is true. So this is that condition we've been talking about. Maybe you're saying something about a sensor value. All right. A lot of times it's involving a sensor value. It's a bump switch, or it's a potentiometer, or it's a light sensor, but you're using that. It's going to run between here. If it's not, then it's going to run what's down here, and that's your if-else statement. Okay, what I'm showing you here real quickly is how we would go about setting this up here. And what I've done here is we've got our brackets here at the top, and I've got my while statement. I'm saying while 1 equals 1, which is always true. Whenever this is true, if my sensor value, which sensor, my bump switch, notice that I've got hard brackets here, and I've got parentheses around the outside here. And I'm saying if my bump switch is equal to 1, well, notice that when I push my bump switch, it's changing to a 1. And if you can hear that in the background, that's my motor turning on. So whenever I hold that, all right, whenever the bump switch is 1, it's going to keep running that motor. Else means when it's not 1, it's got the motor and it's stopped. And that's what's happening here. Other things I want to point out to you, after the while, we got to have the brackets, curly brackets before the while. There's no colon afterwards. Then I have a bracket again because now I'm starting my program. I have my if statement, no bracket, it's not a command. And then, but here I've got to have my brackets again. Start motor. Okay, so this is a command. Else, it's not a command. It's just telling me what to, telling the motor or the computer what to do. If it's not getting a bump switch reading of 1, have the motor be stopped. Is basically what you're saying. The other thing I want to point out is your curly brackets have to match out. Here's a left. Here's a right. Here's a left. Here's a right. Here's a left. And here's its right. Here's left. And here's its right. Notice that for the if statement, I went in, and this is what's happening if this is true. For the else statement, I indented, and this is what's happening for the else statement. Well, hey, that's it for today. Hopefully this helps you a lot on your assignment. I'll catch you guys.